Today we're going to review our Unit 6, which was on probability. Before you watch this video, please make sure that you've gone over the notes that I've included on the Google Classroom for this unit. This will give you information about dice and cards and some definitions. So our first question that we're going to be looking at is to calculate the theoretical probability of the following events happening. We're going to give our answers as reduced fractions, decimals rounded to 3 decimal places, and percentages rounded to 1 decimal place. Now, reduced fractions are also sometimes just called simplified fractions. So our first one is the theoretical probability of rolling a 3 on a regular die. So regular die is a 6-sided die. So we have a 1 out of 6 chance of rolling a 3 because it has the numbers 1, 2, 3, 4, 5, and 6. We can't reduce this fraction any further, so that's our reduced fraction, and now we want to put it into a decimal. So in order to do that, we need to do the top number divided by the bottom number. So we're going to do 1 divided by 6, and now we're going to round this to 3 decimal places. This gives us approximately 0.167. So on your calculator, it'll say 0.166666. You need to make sure that you're rounding to 3 decimal places. So we have our reduced fraction, we have our decimal, and now we're going to do our percent. Now to get our percentage, we take our decimal, 0.167, and we multiply by 100. And that's going to give us 16.7%. So for each of these questions, there's going to be three parts to the answer. So 1 over 6, that's our reduced fraction. 0.167, that is our decimal rounded to 3 decimal places. And then we have 16.7%, that's our percentage rounded to 1 decimal place. Now we're going to do the same in each of these cases. So part B, choosing a heart from a regular deck of cards. So regular deck of cards without jokers has 52 cards in it. And a heart, that's one of the 4 suits. There are 13 hearts. So again, refer back to the notes page if you're not sure where these numbers are coming from. So there's 13 hearts out of those 52. So we're going to write 13 on 52. So this is our fraction. But this fraction can be reduced. And that's because we can divide both 13 and 52 by the same number. And that number is 13. So both of these are divisible by 13. And if we do that to the top and the bottom, 13 divided by 13 is 1, and 52 divided by 13 is 4. So here's our reduced fraction. Now to get it into a decimal, we do 1 divided by 4, and that's going to give us 0.25. We don't need a 3rd decimal place there because it's exactly 0.25. And now to get it to a percentage, we want to do 0.25 times 100, and that gives us 25%. And that's exactly 25%. We don't need to put another decimal place. We don't need to put 0.0. Okay, let's go on to part C, rolling 2 dice and getting a sum of 7. So if we are rolling 2 dice, we're getting a sum of 7. That means we're adding our numbers together to get 7. So you can take a look at the chart on the notes page to help you with this, or you can think about all the different combinations that add up to get 7. Okay, and there's going to be 6 of these different combinations that add up to get 7. So we have 6 on 36. This can be reduced because we can divide each of these by 6. So 36 can be divided by 6, and 6 can be divided by 6. And that's going to give us 1 over 6. And we don't even need to do our other calculations because we can just look up above to part A to know that our decimal is going to be 0.167 and our percent is 16.7. Let's move on to part D. So part D, we're rolling 2 dice and getting a sum of 9 or 5. So let's just take a quick look at what we're really doing here instead of just saying refer back to the table like I did with the last question. So if we are trying to get a sum of 9, we can roll one dice and get a 6 and the other dice and get a 3. We can roll one dice, get a 4 and the other, one get a 5, the other get a 4. And those are the only combinations we have that are going to give us 9. Now we can also do it the other way though, 3 and 6 or 4 and 5. So this gives us 4 combinations for 9. We can do the same thing for the number 5. So we could roll a 1 and a 4, or a 4 and a 1, or a 2 and a 3, or a 3 and a 2. So there are 4 combinations right there. So 4 plus 4, that's going to give us 8 in total. And there's 36 possible combinations when you're rolling 2 dice. So we end up with 8 on 36, and we can reduce this fraction because both 36 and 8 are divisible by the number 4. So 36 divided by 4 gives us 9, and 8 divided by 4 gives us 2. So right here we have our reduced fraction. 9 divided by 2, that's going to give us 0.22222 and so on. So we round it to 0.222, only 3 2's. And if we multiply that to get our percent, we multiply by 100, we get 22.2%. Okay, let's do 2 more, then we're going to move on. So E, we're going to roll a single die and get a 2 4 times in a row. So if we roll a 2 once, we have a 1 out of 6 chance of doing that. And we can do that again, right? So every time we have a 1 out of 6 chance. And we're going to multiply these together. Okay, so we're rolling a 2 4 times in a row. This, if we want to simplify it, is the same as 1 over 6 to the power of 4. Okay, and we did our power of a power rule. This is the same as 1 over 6 to the power of 4. And 6 to the power of 4 gives us 1,296. So for our fraction, we get 1 out of 1,296. Now our percent, it's going to be very, very small. It's actually going to be, so if we do 1 divided by 1,296, we get 0.00077 and so on. So to round it to 1 decimal place, we are going to round to 0.001. And if we multiply that by 100, we get let's do it in blue, we get 0.1%. Okay, our last one of this type. What are the probability of choosing a face card from a regular no jokers deck? So a face card. Face cards are kings, queens, and jacks. So in a deck, we have 4 jacks, 4 queens, 4 kings. And so in total, that's going to give us 12 cards. So this is a regular deck without the jokers, so we get 12 out of 52. And both 12 and 52 are divisible by 4. So we can reduce this. So 52 divided by 4 gives us 13. 12 divided by 4 gives us 3. So our reduced or simplified fraction is 3 out of 13. And if we do 3 divided by 13, that gives us approximately 0.231. And as a percent, that's 23.1%. Okay, next up, we're going to look at spinners. So we're going to use our spinner below, which has the possibility of that little arrow hitting a 1, 2, or 3. And we're going to draw a tree diagram for 2 spins. And then we're going to be listing all of our probabilities in fraction form. So every time that we spin this, there's 3 possible places this arrow could be landing. So for our spin number 1, it could land on 1, it could land on 2, or it could land on 3. Okay, so 3 possibilities with our first spin. Now we're going to spin it again. And when we do these tree diagrams, really what we're looking at is we're looking at combinations. Right? We're looking at what 2 things can we get in a row. So if we spun a 1 the first time, the second time we can also get a 1. We could also possibly get a 2. We could possibly also get a 3. And this is going to be the same for 2 and 3 as well. So if we spin a 2 the first time, the second time we can still get a 1, a 2, or a 3. And same with spinning a 3. So 1, a 2, or a 3. So now we've spun twice and we've done our tree diagram. And these tree diagrams only work when you have an equal chance of landing on each number if we're using a spinner, or if we are flipping a coin, like an equal chance of each outcome. So each outcome has an equal chance. Okay, so now that we've done our spins, we're going to look at the probabilities of the different combinations. And there's kind of a couple different ways to think about this. So probabilities of different combinations. So the first spin, or not the first spin, but the first possibility is that we get a spin 1 the first time and then 1 the second time. So 1 and a 1. We could also then spin a 1 first time, 2 second time. So 1 and a 2. Or a 1 and a 3, a 2 and a 1, a 2 and a 2, a 2 and a 3 and a 1, a 3 and a 2, or a 3 and a 3. So there are 9 different combinations if we look at it order-wise. Okay, 9 different combinations order-wise. So this means there's a 1 out of 9 chance for each combination. For each combo in that order. Okay, it would be different if we said the order didn't matter, right? Because you could say, well, 1 and 2 is the same as 2 and 1 if order didn't matter. Okay, let's move on to our next question where we're going to be analyzing a graph. So this is a frequency graph, and frequency really just means the number. Okay, and our frequency graph below shows the experimental data from fish captured in Cold Lake. So basically, someone's gone into Cold Lake and has captured a bunch of brook trout and has measured their length. So we have number of fish on the vertical and length in inches on the horizontal. And our first question is, what is the probability that a brook trout would be 9 inches in length? Well, the first thing we need to do is we need to actually figure out the total number of fish that were captured. Okay, so we can't do part A until we figure that out. So total number of fish, I'll put brook trout, and that means we have to count. Okay, so our first one, our first column there, we have 1. Our second column, we have 5. Our third column, we have 3, and they're not really columns, they're bars of a bar graph. We have 6 and 2 and 7 and 7. So if we add all of those together, then we are going to get 32 brook trout in total. So we're going to be using that number. So what is the probability that a brook trout would be 9 inches in length? So those that are 9 inches, okay, are right there. So 9 inches in length. So there are 6 of those. So there's a 6 out of 32 chance that they would be 9 inches in length. And let's not just represent with a fraction, even though I haven't specifically asked this. Let's go through, we'll practice our decimals and practice our percentages. So as a reduced fraction, 6 and 32 can both be divided by 2, and that will give us 3 over 16. And if we do 3 divided by 16, we can write that as approximately 0.188, or as a percentage, 18.8%. Part B, what is the probability that a brook trout would be less than 9 inches? So if we're talking about less than 9 inches, we are looking at those that are 6, 7, and 8, because there are none listed as 3, 4, or 5. So those are 9, right? So 1 plus 5 plus 3, that's going to give us 9. So we have 9 on 32, and we can't reduce that fraction any further. We can write it as a decimal though, as approximately 0.281, or as a percent as 28.1%. Okay, and lastly, what is the probability that a brook trout would not be 11 inches? So not 11 inches, let's just do a quick circle of what we are including here. So all of those that aren't 11 inches, so 12 inches, 10 inches, 9 inches, and 6, 7, and 8 inches, so not 9 inches. If we add all of those up, there are 25 other fish that are not 11 inches. Or you can look and see, well, there's only 7 that are 11 inches, right? There's 7 of those. So 25 are not 11 inches. So we have 25 on 32. And we can't reduce that fraction anymore, but we can write it as a decimal that's rounded, 0.781, or as a percent, 78.1%.